There, today we will look into something completely new, and it has always fascinated me looking at this. There is a new systems programming language known as Rust, and I've been hearing a lot about it. And I thought of taking a dive, taking a, getting my hands uh, involved in some Rust projects. So then let's today do a quick Rust introduction. And what is Rust actually? And this is why do we need a new programming language? Since if especially if you have come from C++ background, you might wonder that why do we need a new programming language? And then we see that why Rust is being talked about as the new thing in programming languages, especially when it comes to the systems programming languages. There are talks like Rust will be used in Linux kernel from 6.1, which is again a very fascinating topic. Like those who have been involved with Linux kernel know that it's all written in C. So going from C to Rust, and what is exactly Rust, and what are the advantages and disadvantages of using Rust, and so we'll look into all those things. But we will start by a Rust Hello World tutorial, or go with some of the very simple, like first when you look at a language, you think about hey, this is sounds like familiar to my previous language. It sounds like completely new language. Some people may say, oh, it sounds similar to Python. Some people may say, oh, it sounds similar to C++, because it's the background that you come from. So when you come from a particular kind of background, you always try to look at new things from your previous background. But without much further ado, I would start with very simple things first. As they say in every programming language, you should start with a hello world program. So we'll look at a hello world program, and we'll see how we can write a hello world program in Rust. So let's start with a uh, hello world.rs, and let's see what should we write. The comments are still the old, the new C or the C++ style. So here we can write my first or Rust hello world program. And I will not bore you guys with typing, so I've already typed something. So as you can see, you always need a main function, which is not a surprise, which is also true in most languages, that main is where the execution starts. So as you can see, there's a println, which is like C's printf, or C out and C in streams in C++. But basically, it's very simple. It also may remind you of Python and Python 3 or things like that. So all you have is a println. They call this a macro, not a function. And it's basically, as you can see, this is a exclamation mark at the end of the println. You don't have to give a new line. So the println will give you a new line at the end of it. So let's change, if nothing else, let's change this string and say hello world from Rust, and hello world from Rust. Okay, and then get out of it. Now you might have to install a Rust compiler, and I will get to that soon. But basically, let's try to just build this, because people want to see fast. Hey, how does it? Is it a compiling program? It's a complete program or not? So let's do a Rust C. C is for compiler. It's like anything GCC or CC or whatever, or G++ for C++. Anyway, so Rust C is the Rust compiler, and you say Rust C hello world.rs and see. Let's see what happens. Now what you see is that if you see ls minus lt, what are the new files that got generated, you would see there is a hello world executable by X sign. You can see it's an executable. So unlike in C where the default executables are called as a.out, Rust actually gives the name of your the first part of the name of your file without the extension .rs as the name of the executable. So now let's run it and see what happens. And lo and behold, we have a hello world from Rust. So we just ran our first Rust program. Congratulations. So now let's see. Now you might say, hey, I want to give it a shot. Again, let me put this program on the screen. Very simple, all very simple, very easy for you to type and start compiling. But then you might say, hey, where is Rust C? So for that, if you are on Ubuntu or other Linuxes of the world, all you need to do is this command curl. And what this curl does is, see this command curl, this is all you need. If you have this command, you can pretty much install Rust C. So curl https this pipe it to sh will basically install Rust C and the things that you would need Rust C. So now you might say, hey, I installed Rust C and I actually went through this, and that's why I want to basically save your time. So you might say, hey, I installed Rust C, but Rust C is not in my path. So when I say Rust C, it says file not found. So for that, you may have to do something like this on a Unix system. You may have to put it in your path. And usually it installs by default in your home directory .cargo bin. So you just have to make sure that it is there in your path, right? So these are just small things that will save you some googling, so just these two commands, curl and that export path command that I just showed you, are enough to get you to have Rust compiler, Rust C, and then will let you start compiling Rust programs. So that was our first program. I just want to put it on the screen again so that you're not confused about it. If you want, you can stop the screen now and maybe you can try in your own terminal. Now let's go to our next program, maybe a little bit more interesting this time, and let's see what happens. So as you can see, we'll start with a let1.rs program now. So what does let1 do? Okay, so now let's start with the variables. So as you can see that I have defined a variable here. Now people who have been coding in other language for a long time might start wondering what's going on here. There is no int here, right? Usually in C you might say int something like int C or whatever, right? Int answer in this case. But there is no int here. As you can see, there is a let, and it says let answer equal to 42. So, and not only that, there is no type like is this answer a int 32, int 16, u8, int 8, what it is. So, so most likely it seems that there is a type inferencing going on from the assignment. So it knows that hey, you assign it to 42. 42 is integer, so let answer be integer. But actually we'll come to it. We'll come to a new program very soon where we will see how to specify the type of a variable. But let's just run it. As you can see, it's looking more and more like printf of C or the hello or the print of Python. You just leave a brace where you want your variable to basically appear. So we'll run this program and let's see what happens. We say rust c let1.rs and it ran. This is very good. Now let's run let1. As we know that executables are created with with the file name without the extension rs. So let's see last one. There you go. So you got hello 42. If you want to see, let's change it. Let's make it, instead of 42, let's make it 420. So now let's run it again. Obviously if you run it now, you won't get it. We have to compile, right? So let's run it again, and here we are, and we have hello 420. So that is very good. Now the next thing is, let's where we can do, oh, so that's executable. So now that's another thing to remember. You just have to always do a .rs to see the source code, source file. Otherwise you'll end up seeing the executable, which will give you garbage in vi if the vi is your editor. Here we are learning that what kind of errors we can get, what kind of macros we can use. Or this is like, if you have been doing C and C++, it's like assert to see if something is true or false. So validity of an assertion. So you can see that answer was assigned to 42, but we are checking, hey, is it equal to 41, which should fail. So let's see that. Let's see if it will compile. So rust c let 2.rs, what happens? Okay, it compiled, of course. It was a syntactically valid program, but let's see what it does when we try to run it. So there we go. We got assertion failed because it says, hey, left was 42, right was 41. So it even tells you can run with Rust backtrace and things like that. So you just learn how to test the validity or equality or things like that. The asserts that we see in other languages is not very surprising so far. It's not any earth shattering. Now let's try to see um, if we have let 3.rs, and I see there is no left 3.rs. So let's do a for 1. Now let's do a ls minus lt. As you know, the t gives us the timestamp, so we can go in what order we wrote these programs, right? So if you see, after let 1, let 2, let's try to learn a little bit more interesting stuff. So we will see if we can do a for loop, or you know what, before we do a for loop, I want to introduce a very, very important topic, and we want to see if for loops, while loops, those things we can always do. So as you can see, this is the syntax. Only thing that is giving you new is a, hey, so far all I see is different ways to do things that I already knew. So what's the big deal? You're saying here print 5 times the hello and the value of the variable I, which is a index for the loop. So what's the big deal? If we were to run this, very trivial as usual, for 1.rs, and it compiled, of course, and you see for 1, and it printed. So you saw that. I guess one takeaway is that when you say 0, when you give the range, the last value it prints from, so the indexing starts from 0, it goes the last but 1, so last minus 1. So that's why it's going 5 times I is printed, but the indexing is happening from 0 to 4. So you got hello 0, 0. So that's very good. Now what we will do is we will see something which is what Rust is. When I started, that's when I thought, oh wow, this is like something completely new concept. So we'll go to that soon, but let's see if we have any. I mean, this is just a variation on the previous. If you want a little bit more fancy, and you go from for to if loops. So now we got an if statement. And one thing that might be surprise to some people is that you don't see here braces. You just simply write I mod 2 equal to 0, and there are no braces here. Like you would think, hey, this should be, in other languages you would typically see these things, right? And I guess even that here you can do that if this is increasing your readability, understand, and you feel the code is much more organized that way. But you don't need to. So now if you were to run this one, all it will do is it will go from 0 to 5. Oh, it says unnecessary parenthesis around if condition. So this is your first introduction, I would say, to Rust, because in Rust compiler is very helpful, very verbose. So as you know that those braces, those parentheses were actually is saying no, you don't need it. But it gave a warning only, not actually error. So I think it was still compiled, I guess. So if you see dot 4.2, and it only said went from 0 to 4 5 times, and then it printed it is even or odd. So this is what I'm expecting. But I say, hey, why you are using unnecessary parentheses? And it is even a surprise to me that the compiler would be so so verbose, and like those things they actually want to point out that hey, you don't need to do that. So now you see again, this time there's no warning, nothing, and you can come. Okay, so we have done 4. Now we are going to do something more interesting, which is that let's do something which is more kind of exposes us to in our first lesson we go home thinking that, well, does sound something interesting going on here. I haven't seen anything like these this kind of a new concept. So we look at uh, instead of going to 4.3, which is I guess okay. So this is another, if you are curious, and this is more like, C has these things too, like in a little bit different syntax where you see you get true or false depending upon, you can write that previous if then else in just one line. You define a variable in odd, and you say if it divide if the output of this expression here is equal to 0, which is explicitly being changed, then the even odd gets the value. This is string even or odd depending upon if I mod 2 equal to 0 or not. But you see the crypticness of all this. There are no parentheses. I would have expected a parenthesis around here at least, right? Because that's how in we kind of trying to group that expressions, thinking that hey, this is happening at one time. This is the one unit uh, of what we want to do, or our thought, or something like that. So now, if you compile this, again it said, hey, no. So this actually becomes a compiler error. It's not just a question of hey, you put in an extra parenthesis to make to give your thoughts a little bit more granularity in that expression, but no, compiler was actually expecting a brace at that point, so that's why I didn't like it. But basically, as you can see, the compiler is very, very expressive. It will give you everything, give you a lot of information, which is a good thing. This is actually, I kind of liked it. So now let's look at something before we part for today from our first lesson on in Rust introduction. Let's do something more, something which leaves us with a new concept, which is, let's do this program now. As you can see, what I will do is I would not have this. I don't want to add. So let's just write add. So all it does is it starts initializes sum to 0, and then it goes from in a loop from 0 to 5 times from 0 to 4, I being 0 to 4, and then it adds that to sum, and let's see if it what happens. So we'll say Rust C, we'll try to compile this, and we'll say add 1 dot rs. Let's see what happens. Oh, there you go. what is it saying? It won't even let you compile. Whereas we think the program is absolutely right. I don't see any problem. He's saying first assignment to sum. Okay, sum was assigned to 0. Consider making this binding mutable. What is this going on here? Now, as you can see, cannot assign twice to immutable variable. Now, this is our first new concept in Rust, which is everything is constant. This is a, I would say, uh, a a new revelation to us, that by default, usually what happens, you define a variable in any language and then you say, hey, I want it not to change. I wanted to make it immutable. You say it's just a constant. So it's a constant. Like in other languages, you might say constant sum equal to 0, or int sum equal to 0. But here you see default is constness. So everything is const. So when you say at this point, actually const is, so here you can say sum is const. So now, unless you say explicitly that this variable will change after I defined it like this is like a new, rather than just saying int sum equal to 0 in C, we have to say let is just always, but we have to add this mutability to sum, saying that sum is actually a variable that can change. If you don't do that, then the compiler won't let you compile this program, because you're changing sum here, sum will change here. So by default, variables are constant in Rust. That is the, when I first came across, it's kind of did make me think, like what's going on here. It like which is kind of a new thing for me, because by default everything is constant unless you make it explicitly state that this is a variable, quote unquote variable, in the sense that it it can vary. For that you have to say it is mutable, and that you have to explicitly say, and then otherwise you can't change the value of the variable after defining it, after declaring it. So here let's go, now let's see now what happens. And it did let us compile, and let's run it now just for the sake of it. And of course it gives us the expected output, which is adding some numbers from 0 to 4 into sum. So now you just came across a new concept in sum. So now sum is now a variable. Here you can write sum is now a variable that can change from this point. So mutability has to be made explicit, and that is kind of something I found kind of interesting, that this language has these features. And you can see, we'll come as we go on, we'll see why the language designers chose things that way, why mutability has to be made explicit. Because as you know, Rust is a systems programming language. So and systems programming language, there are a lot of issues related to pointers, like in C, or in C++ less, but in C especially, where you have things changing underneath us without our intentions and things like that. So you have so I guess because this was going to be a systems programming language, which can even be used to write some modules in Linux kernel and write kernels and things like that. So you want these things to be explicit. So the mutability has to be made explicit, and that is the concept we will take from our first lesson, which is that in Rust everything is constant by default unless you explicitly state that this variable can change, and then we have to add the keyword mut for mutability. And with that, I will leave you thinking about what we went through today. We saw some of the program, some simple things like how to define a new variable, how to make it mutable. We saw the structure of the loops. We saw that the parentheses are not required at all. So, in our next chapter, we would look into more features of Rust and how Rust is taking a new path or a new highway to basically define or use the features that we need in a programming language, and how Rust's way of dealing with familiar features, things that we are familiar, is slightly different or very different from other languages. So I will leave you with this interesting thought that in Rust everything is constant unless you make it mutable explicitly. And with that, I would let you guys go and explore some of the things that we talked about. Until next time, adios.